Hello everyone, it's December 21st. Alright, let's get to go. Still vacation mode. We're talking about a chicken. Oh, probably a duck.
Duo.
Oh, duo. Yeah, that is correct. Maximum score after splitting a string. Given a string of 0 and 1, return the maximum score after splitting the string into two non-empty substring, left and right. The score after splitting is the number of zeros in the left plus the number of ones in the right. Okay, yeah, it's pretty straightforward. It's going to be, it's like slide window-ish thing to go. So we're gonna just count the number of ones, right, on the right, and then count number of left, 0 on the left, and we put in here, and then just go one by one, and then we'll compute. Okay. It's not very hard. Of course it's not hard. It's an easy problem. What do you think, man? All right, here we go. So we're gonna have an int left, int right. Okay, and then what we're gonna do is count everything in the left. So we can say, in fact, let me redo this. I don't like how I do it because the left. Okay, well the string, the size of the string is at least 2. Okay, that's fine. So left is to count number of zeros, right? Number of zeros in the left. Okay, so this one shall be s dot char at 0. Okay, is that equal to 0? Okay, if it's equal, that'll be 1, otherwise it'll be 0. And then for this, we're gonna say for int I equal to 1, I small s dot length plus plus, and then we're gonna do is if no, I don't want to do that. I can just say right plus equal to s dot char at I, is that equal to 1? If equal to 1, we do 1, otherwise we do 0. Okay, so with that, we have with that we have left and right, and then what we're gonna do is we'll do it one more time for int I. Oh, hold a second, let me get it. Int res equal to, we want to find the maximum. Okay, so we start with 0. For I equal to 1, I smaller than s dot length. That is not. So I will be the start of the right substring. Yeah, that's correct. That is correct. All right, so what we're gonna do is so each time we start. Ooh, that is not. Hold a second. So I think we have to go. Every time we do this index, we will add the previous. Yeah, I think. Yep. I'm gonna change this. I think I should just start with 0. And this is actually start with 0. Okay. And the rest is this. So every time we do this I, we will update. Okay, we update the left and right first. So how do we update left? So we say left shall be plus equal to s dot char at I minus 1, right? Is that equal to 0? If it's equal to 0, we're gonna do 1, otherwise we do 0. Alright, so we update left and then we update right, minus equal to s dot char at I minus 1. Ooh, I think, can we do this? Yeah, maybe we can do this if s dot char at I minus 1, right? If that's equal to 0, then left plus equal 1, and right don't make any change. Else, right minus equal 1. So if it's a 1, so we do that. Alright, we delete these two. So once we've done this, we'll say res shall equal to math.maximum res and left plus right. And then at the end, we return res. Okay. Give this a shot. Alright, looks alright. Let me do this. And then do some random stuff. Looks good. Okay. Done. $14.22. Yeah, there's nothing more to say. We'll just do this. Okay. Okay, back here. Let's take a look at the solution. Rule force, count left and right. One pass. Huh. One pass. How'd you do this one pass? One pass. How'd you do one pass? Number of 1 on the left and number of zeros on the right. Huh. If it's 1, 1 plus plus. So we get 1 and zeros. So we get a 1 encountered so far. We get a 0 encountered so far. So what we want is 0 minus 1s. Hold on. So what we want is the 1s plus the zeros, right? 1s plus the zeros. What we know is... Hola, hola. 1 and 0. There'll be 1 here and a 0 here. So if I know the 1s and zeros on the left hand side, I know you add them together. This plus this plus this plus this equals the total length. Oh, what is this? What is this? Zero is the number of zeros on the left. OR is the number of ones. Yeah, 0 on the left, 1's on the right. We can express OR as OT minus OL. OT is the total number of ones, and OL is the number of ones on the left. Oh, I think I know this. So we say the number of zeros on the left, the number of ones on the right. If I know the total number of ones, then the total number of ones minus the number of ones on the left. So the total minus the one on the left plus the number of zeros on the left will equal to, so the total number of ones is a static value. So the total number of 1 minus, or basically plus, the number of 0 on the left minus the number of ones on the left. We want to find the maximum of this, which is to find a maximum of the number of zeros on the left minus the number of ones on the left. Holy crap, this is great. This is great. Why do we do this? We know the zeros, we know the ones, right? And then when we're done, shouldn't, wait, hold a second. Wait, what?
I'll read another room.
Huh?
I'll read another room.
Okay, yeah.
Then I'm going to eat.
Yes.
Something like that.
Oh, yeah. Enjoy. Disfruta. Disfruta tu meditación y tu libro. But I don't understand why this is not small or equal to. This is weird. Why can't we do a small or equal to here? Oh, because yes. Because if it's smaller or equal to, yeah. Oh, that's a trick. That is a trick. The total number is 0 because the total number of we can now go to the right. Right? Hold on. 1 is on the right, which is the total number of ones minus total number of ones in the left. So based on where the position is, so we put a position here. This total number. So yes, so wherever the index is, it's included on the left. Perfect. That's great solution. Oh my goodness. This is the, yep. This is the one pass solution from the official solution. The key idea is that we can convert the score from num 0 left plus num 1 right to num 0 left plus total 1 minus num 1 left. Thus, we can do one pass and keep track of the number of ones and zeros on the left and find the maximum of num 0 left minus num 1 left. At the end, we find the total 1 and we will have this, the result, the answer. One trick is that as we iterate through the string to find num 0 left and num1 left, we do not iterate the entire string, because wherever the index lands, it will be the end of the left substring. And since we cannot have an empty right substring, the iteration must terminate before the last element. There we go. Alright, so I guess we have to change almost the entire thing. So how about we just delete everything? So we just say, yes, once, 0, 0 is 0, okay? And then for int res is equal to 0. For int I, 0I smaller than s dot length minus 1 I plus plus. And we say if s dot chart I is equal to 0, right? Then zeros plus plus plus. Oh, what did I do? Plus plus. Else 1 ones plus plus. Maybe zeros is es. I have no idea. Yeah, it looks weird, right? Alright. And then we say if s dot length, s dot chart, s dot length minus 1, the last one, if it's a 1, then ones will be plus plus. Oh, hold a second. Where is your update? Res shall equal to maximum math.max res and zeros minus ones. And then we'll return res plus ones. Seven. Oh, what the hell? Hmm? Which one's wrong? Oh, ones is wrong. Should now be 4. Maybe this cannot be 0. You know? Yep. Yeah, because I think what happens is this is negative. Ah, yep, this is negative. Good catch. Well, it's not good catch. Actually, I saw the solution, so I knew it was wrong. So I'll do this. All right, now we can move on. So let's move on. Oh, another easy question. That's fine. That's fine. Longest alternating subarray. Hold on. Let me see. We are 19 minutes in. So if we do 1 hour, so I have 40 more minutes. So 740. Okay. All right. Given a zero-indexed integer array, a subarray S of length m is called alternating if m is greater than 1. Okay, m is greater than 1. S equal to S0 plus 1. S1 equals S0 plus 1. The zero index subarray looks like this. In other words, S1 minus S0 is 1. S2 minus S1 is 1. Wait, hold a second. Wait, what the hell? Okay, we give an array, a subarray S of length m is called alternating if we have more than one and the next always plus 1. Ah, I see. In other words, this. Okay. And so on up to this. Return the maximum length of all alternating subarrays present in nums, or -1 if no such subarray exists. Okay, so alternating subarray, so it's always just A, B, A, B, A, B, right? A, B, A, B, B, A, B, A. It has to be like this. So this will be this 3, 4, 3, 4. Yeah, because you have to okay, the alternating subarray 3, 4, 3, 4, 3, 3, 4, 3, 4. 4, 3 is not. Okay, 4, 3 is not. Gotcha. 4, 5. Okay. I like to write, but I don't have a no writing. Just pure brain power. So if we iterate, right, from left to right, and whenever we find one, like 2, 3, then we keep going. The next one has to be, smaller. If the next one is bigger, then it doesn't work. You have to restart, right? You have to restart. And the next one, if it's too small, it has to restart as well. No. We start with the second one, and then we check. The second one we check with the previous one, right? And if it's not equal to 1, we always restart until we find one that works, and then we check, and then we go next one, and we see if the previous difference is 1, right? And then if the previous difference is 1 and the current difference is -1, then we just keep going. And then if the previous is -1 and the current is 1, then we will keep going, right? We keep going until the last, which means we have the current difference and we need the previous difference. And the previous difference when we start can be, 0. Doesn't matter. So I will store the previous difference. Maybe we don't need to store the previous difference. The size is 2, right? The size is 2. And okay, I have some idea. Okay, I think we can Java this thing. Let's try this. So we don't need the previous because we can compute the previous. What we need is res. I will start with 0. Okay, and we will start. What will be the? Maybe have a previous will be easier to deal with, right? Be easier to deal with. And this is 2. It'll be easier to deal with. So what we can say is int pre. Let's call it 0. Okay. Then we can say for int I equal to 1, I smaller than nums.length, I plus plus, right? We say current difference is nums I, okay, minus num I minus 1, right? And then we say if current is equal to, oh, we also need a length. We start with 0. Okay, so if current is equal to 1, okay, then we say if the previous, right, if previous is equal to minus 1, then len will plus plus. Else, if the previous is not minus 1, then len will equal to 2. What's wrong here? Oh, that's fine. Right? So it's for current is 1, and then else if current is equal to minus 1, right? And we say if pre is equal to 1, then len plus plus. Else len equal to 0, because current is a negative 1 but previous, so len is still bad. I'm pretty sure we have to update the pre, right? So pre shall equal to current. It's the same thing. Pre shall equal to current. Else, what's this else? This else is current is not 1, and then pre will equal to current, which I think we can do pre equal to current here, and here we just reset len equal to 0, right? It's not that, so we should reset to 0. But before we do any of these, should do it here, right? Yeah, we should do it. Every time we reset, before we reset, we shall update. So right here we reset, here we reset, and here we reset. So every time we reset, so which means I don't like this at all. Can we yeah, I don't think so. That's okay. So we do here, right? So the res equal to max res and len before we reset it. Here's the same. We have to add these res is math.max len, and then we don't have to do the pre, it's not necessary, and we have to do the one more time, res equal to math.max. Okay, and then once we're done, we say return res if res is res equal to 0, if res equal to 0 minus 1, otherwise we return res. Okay, let's see if it's right. It's a little convoluted though. Nope. That's interesting. Okay, so we start from this, right? And current is a 1. pre is not -1. Pre is this. So now line equal to 2. Right? Line equal to 2. And pre shall equal to 1. Next time is 3, 4. Current equal 1. Pre is not this. So rest updated 2. And the lines become 2 again. So it's 3, 4. And next time, current is -1. Pre is 1. So line should be 3. Oh, because at the end I never really... So... Okay, so it should be rest equal to math dot maximum rest and line. Then I return. Okie dokie. I think now it's time for us to make some changes. Okay, which I think we can do change. Okay, so if current times pre is equal to -1, right? If that's the case, then we'll do len plus plus. Otherwise, we'll do rest equals math dot maximum rest and len shall equal to current equal to 1. If it is, will be 2. If it's not, will be 0. And we'll do D all the way to 19. J. This one we need. Right, update the pre. I mean, yeah, and at the end, rest shall equal to math dot max rest len. Okay, so this one seems to be more. Nope. Nope. Come on. Try it. Oh, lordy. One. That is interesting. How? 3, 2 is bad. That's -1. Now 2, 3. Oh, I think I know. Hold on, but if I have -1 starts, why will be 1? So current is -1. Pre is 0. Now pre is -1. Current is 1. Yeah, that's... Yeah, there's a little bit issue. Trying to be smart. Maybe it has to be the previous way. With all the analysis. Oh, it's not correct either. What? Hold a second. So initially current is 0. So it's nothing. Len is 0. And then still 0, 0. And then we're going here. 3, 2, right? So now it's -1. We check this. Pre is 0. So we do this. Still nothing. Len is 0. So now pre equals -1. Now it's 2, 3. Pre is -1. So now it's 1. Pre is -1. And then line become 1. Oh. Ha. Okay. Pre. So current is 1, but pre is -1, but pre starts with -1. That is the problem. So what I think is when current is -1, but pre is not. So we need to reset the current. Yo, this is interesting. This is we have reset current equal to 0. Oh, dude. Oh my god. Yeah, this is when current is -1, but pre is not 1. We cannot use the current. We cannot use -1 as the current because it does not represent a valid subarray. Something like that. It's so convoluted. Oh, definitely not a fan of this. This is not a big fan of this solution. Convoluted. Well, let's see if people have better solutions. So this is gonna be Vim and LeetCode what? 2765. 65.java. Alright, let's see. 2 pointers. 2 pointers. So 1 point, keep moving forward. So we check if these 2 are good. Oh, holy crap! I'm going forward. Right, if these 2 are good, then I will just move the right forward. I can do that. So we find a good start. Then we can move forward. So we just need to check this is equal to this. And this is equal to this. So it go once it's bad, so we get something. Once we get something, we move both forward. Then why do you need 2 pointers for? Because you need to know where is the starting point. I kind of know what this is trying to do. You want to try the 2 pointers, at least the 2 pointers in my mind? Yeah, so you start from position 1 and you check if it's good, then you do the 2 pointers, right? And whenever you end, that will be the current array. And then the next one will be bad, so you keep checking. So I'm trying to see is hold on, let's see. So here is what I think. Try 2 pointers, right? Then we can say no ij. Yeah, j will be the front. Okay, for int I equal to y smaller than nums dot length plus. Alright, if nums I, okay, minus nums I minus 1 equal to 1, okay, then into j equal to I minus 1. This is the starting point, okay? Starting point. And then we can say int I equal to I. Let's do k. I plus 1, okay? While k is smaller than nums dot length. Ooh, that is not right. I equal to 1. We'll do this while I smaller than nums dot length. Okay, so this was good. This is not necessary. And then while I is smaller than this. Okay, so I think it's inside this whole thing. And okay, what we want to do, I actually want to I plus plus, okay, and then well this and something we'll do I plus plus, right? So what is the something? So first is nums I is equal to nums I minus 2, right? Minus 1 minus 2. These are the same, right? And if this is the same, we'll fall. Oh, we don't need this. I think this one is sufficient. Wow, yeah. Well, I is equal to I minus 2. Done. Move forward. I equals I minus 2. Done. Move forward. I minus until we have something is not equal to. Okay. Well, when it's not equal to, then rest shall equal to math dot maximum rest and I minus j. That is the length. And then I plus plus. Right? Because this is the first time this is not equal to this, not equal to I minus 2, which means their difference is not going to be equal to 1. Right? It's just, it's out. It's out. It's out. Once it's out, then we do I plus plus, and then we keep going, and then eventually we will return hold on. So when we go to the end, it could be just, you know, I plus 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 plus. Oh yeah, because it did it here. We get out. We already compute the rest. So no matter what, I can just return. Okay, rest equal to 0. Right? If it's, we return -1. Otherwise, we return rest. Why this return is in this color? What the hell? Okay, I think I just selected it. All right. Oh wow, I have lots and lots of test cases. Oh gosh. You didn't update J, did you? No, it doesn't matter. It does not matter. Alright, so we start I is 1. So the first one is true. J equal to 0, I plus plus. That's not true. And so I is 4. I is this position. So that's 2. Good. And then I plus plus. Ooh, I should not do I plus plus. Yeah. You're skipping. Oh, come on. And then else, right? Something like this. Yeah. Sounds about right. Yep. 2 pointers. This is the right, quote unquote, the right solution. Simply because it's, you know, it's easier to reason with. Dude, what the hell? This select and copy thing doesn't work all the time. Yeah? No way. This copy doesn't work? Copy. Huh? Unsure. Don't know what happened. Don't care. Alright, so we're done with this. Move on. We have 10 minutes. Jesus. Alright, we want to relocate marbles. You're given 0 indexed integer array nums representing the initial positions of some marbles. You're also given 2 0 integers index integer arrays. Move from and move to of equal length. Throughout the length steps, you'll change the position of the marbles. On the ith step, you'll move all marbles at position move from to position move to. After completing all the steps, return the sorted list of occupied positions. We call a position occupied if there is at least one marble in that position. There may be multiple marbles in a single position. Initial position of some marbles. So we just move them around. And what if you have, it's a list of integer. There is at least a marble in move from at the moment we want to apply the ith move. Should move everything from position 1. And what's your return? Sorted list of occupied positions. Sorted list of occupied. Oh, which ones are occupied? Damn. Gotcha. Which one is occupied? All right, so we start from position 1, 6, 7, 8. The first step, we move from 1 to 2. So 1 is not occupied, 2 is occupied. And the next step, we move from 7 to 9. Okay, 7 to 9. And 9 is occupied. And every time we move all the balls, right? All the balls. And next one, we move from 2 to 5. So 5 is occupied, but 2 is no longer occupied. So what we're saying is every time we do move from, those positions are always have something because that's according to the requirement. There are at least a marble in this position at the moment we want to apply the ith move, right? And every time we apply the move, we always move all the marbles from this position to the next position, which means the move 2 will always be occupied. Are you okay? All right, let's call it off. I will see you guys tomorrow. Adios.